Hello everyone, welcome back to LeetCode Daily Live where I do the daily question raw and uncut. So we have a medium today, it's called longest unequal adjacent groups, Subsequence 2. So what are we given? So we are given a an array of string called words and also some groups. So it is a bit similar to yesterday's. Is it just that this one has more? Yeah, so compared to yesterday, um, well, the worst length is still the same. Um, but then the total number of words is like 10 times more. Words are distinct. I don't know why it has to be distinct, like from yesterday, but yeah, let's just read the question. Yeah, also, I finished all my exams, so I can finally be a bit more consistent. So yeah, let's not get distracted and just do the question. So having distance between two strings of equal length is the number of positions at which the corresponding characters are different. Right. So we can find um every pair of like Hamming distance between every pair of strings. So you need to select the longest subsequence, such that for the sequence denoted um by this having length k. So subsequence means that yeah. So like the array, like basically it is a non-contiguous subarray, but you have to like keep the order. So that's what a subsequence is. So for adjacent indices in the subsequence, their corresponding groups are unequal. So adjacent, their group has to be not equal. Um, so words ij and ij plus 1, they have to be equal in length as well, and their Hamming distance has to be 1 for all indices. Right, so there are a lot more restrictions compared to yesterday's. So yesterday we are just looking for the longest, like the longest subsequence you can form. This one, so return a string array containing the words corresponding to the indices. Right, so yeah, we want to return the words so that our length is the longest. Is it? Wait, wait. Did it say it wants the longest? It never mentioned anything, right? Is it just like any subsequence? Surely not, right? Oh yeah, longest subsequence. Yeah, there it is. So yeah, so also the string in words could be unequal in length. So in that case, I think like if you have like um if you have AAA and AAAA, I think that should still be counted as like one difference. So like that's how we will deal with the unequal length thing. So input words. Yeah, so let's look at some examples. So this one, well, if we pick the first one, uh, we can pick. Yeah, so there are two solutions. So like we can pick the first and second, like because they have a Hamming distance of 1, so only the first character is different, right? Um, so that's the same for like the first and third elements, and we can't do longer than that. And also like we have to worry about the groups as well. So yeah, um, yeah, I think like when I see the bound and also see like all the restrictions, the first thing that came to mind is definitely a DP. Um, so how I define a DP state here? Because like I don't think greedy would work here that well. Um, because like let's say we choose the first one, but then the first one has a Hamming distance of like more than 2 any other like any other strings, then that kind of like messes the thing up, right? So yeah, I think like DP would make a lot more sense here. Yeah, we don't really have to look at this example, I guess. Yeah, also this time groups could be a lot more different. So we have to think about that as well. Yeah, so actually let's have a look on DP and like how we could potentially solve this with DP. So yeah, maybe we can look at example one. It's like, and then like maybe we can change a tiny bit to just like cater for the different cases. So we have this here. I think like what we can do is we can set DP. So whatever is in DP would be the longest subsequence from 1 to I. So like this, like, so I would be the index in DP, right? But then we also have to store the predecessor, I think, because like we want to actually find the actual words string at the end. So instead of like just find the length, we want to find the actual string. So we also need like a predecessor. But basically like how I'm thinking it will work is so well the base case is easy. Like you just pick itself, right? So well you just pick BAB, so you have a length of 3, there are no predecessor, so we can just set it as -1. When we look at 2, so that means we can account, like we can use the first 2 words now. Well, we have to look which ones we can link it back to. So like DAB and BAB, it has a like they have a having distance of 1, and also they have different groups, right? Like if you remember, the groups are like 1, 2, and 2. So yeah, therefore like we can link it back to that, and then so we can find the maximum. Well, actually, like the DP would have stored the longest subsequence. It can form up to BAB, right? So DAB can just add to that. So we'll have 6 here, and then well we'll have the predecessor as like 1, like because it links back to BAB. So let's look at CAB. Well, CAB, it doesn't work with DAB because they have the same group, but it works with BAB, right? So that's like the easier case. But let's say it has group 3 right now. Oh yeah, does it say so yeah, okay, so only adjacent groups have to be unequal, I think. I think that's what it says. Yeah, okay. So that means like if it is CAB, well, we can first look at BAB, right? And that'll work because like they have different groups. Their having distance is 1, but well, actually not but like we can still put it here. But when we look at 2, well, it also works linking here, right? So but this one is actually more optimal because it has a longer subsequence already. So that's why like we'll link it that way. And then at the end, we just want to find the maximum index. And then we can just use the predecessor to keep like going back until we reach -1. So that'll allow us to get the actual words from the subsequence. So yeah, I'm pretty confident that'll work. So let's just code that out. So what do we have at the beginning? So we need a DP state. So we will set it as I guess we can set it as -1 for well I guess every sequence can contain itself. So let's just set it as length of word for word in words. I think we can do that at the beginning. And then we have a predecessor, so we will set all of them to be -1 first in words. So now I think we also need a function for having distance. So hamdist. So we have string s1 and then we have string s2. It should return an int. So what we should do is for I in range, well, we can take the minimum length of s1 and s2, and then at the end, well, if s2 has a length of 5, s1 has a length of 3, we know that the extra characters will add to the Hamming distance anyways, right? So yeah, like we can just like add more afterwards, basically. So distance, we set it to be 0 at the beginning, and then so if s1i is not equal to s2i, well, we have to increase the Hamming distance, and at the end we just want to return the distance plus the absolute value of length s1 minus. So that will find the number of different bits, or like the extra bits, basically. So now we have that function as well. I think we should be good, like to actually run the DP now. So for the predecessor, it should be fine. So that's the base case. So we don't have to look at the first word, I'm pretty sure. So what we want to do is for I in range 1 all the way to length words. Yeah. So we just want to check for j in range all the way up to I. Yeah, so like when we are looking at the first index, we only want to check like from 0 all the way like right before 1, right? When we look at index 2, well, like I've one index based. Like I'm using one index base like when I was drawing out, but like we should really use 0. So like when we have a 2 here, we only want to look at the first 2. So that's where this comes from. And then what we can do is we can just do if words, I guess like hang distance. Maybe we can test the groups first, because that's a bit faster. So if groups I is not equal to groups j, and having distance, I think that's what I got. Yeah. So having distance of words I and words j is smaller or equal to 1. Well, that means it is a valid. It is a valid one that we can do. So like dpi will be equal to the running max, so like the current longest, or we look at dpj. I guess we should actually check that up here as well. So dpi is smaller than dpj plus the length of words I. So that will give us like if we use the j subsequence so far and add the word I in it, if it is longer than what we had before, like the running maximum, then we want to change that, right? So the reason like we want to do this is we want to know exactly when to change the predecessor as well. So words I, and then we have pred I should be equal to j, because now we're using the j chain. So after all these, we want to find the longest subsequence now. So we have index, and then I guess like longest. Just set it as like let's just do like -1. So now for I in range, length of words. So if dpi is larger than longest, well, we want to wait, not increment. We want to set the index to be 1, and we also want to set longest to be dpi. So after this, we are going to find the position like that has the longest subsequence, right? So like in our example, we're going to see that like CAB is going to have the it is going to, well, basically be the last element of the longest subsequence we can form, and therefore like we will have the result and then so now we have index there, so we can just do like while index is not equal to -1, because that's the default we set when we don't have a predecessor. So while it is not -1, we want to add words index in there, and then we want to set index to be the predecessor of index, so we can keep looping back. And then at the end, we just want to return the reversed version of res, because like from here we will go from back to front, but we actually want like front to end. So I think that should work. Well, unless I code up something wrong. Well, where is it? It's not valid value for the expected return. Yeah, of course. I always forget about this. So like when you do reverse, it actually returns an iterator, which is not a list. So that's why and it wouldn't convert to a list. Oh, oops. What did I do wrong? So what I have is BDD and BD. Oh, they don't have the same group. Wait. It seems like I'm misunderstanding the question somewhere. I think with the Hamming distance, maybe. So, is that not allowed? Oh, right. So, for words, it is only if they are equal in length and the Hamming distance between them is 1. So if they're not equal in length, I should just set the Hamming distance to be infinity. Yeah, so instead of doing this, we can just go up here and do something like if the lengths are different, we just want to return, I don't know, I just set it as like 1,000,000, because that'll work, and then we don't need the minimum here, although it doesn't really matter. It just makes it a bit nicer. Yeah, I think it should work now. It still doesn't work. Oh, did I misunderstand what longest means? It wants the longest subsequence, but I really don't like how this question is being worded. Well, I guess like this one is kind of my bad, like, cause like I should have read that. But like longest subsequence, it could mean like both character-wise or index-wise. So I guess in this case, what we will do is we'll set this as 1 at the beginning, and then we can just do we just do like 1 here. So like instead of the longest character string, they actually want the longest count of words. So if we change it to +1, it should work now, I think. Let's use the test case. Yeah, I really don't like how this question is getting phrased. It's a bit similar to like yesterday's questions problem. It's just extremely wordy, and like, yeah, it takes like no effort to actually do the question yesterday, but then understanding the question took most of the time. I think like those questions are not that good. But well, that's just my opinion. Maybe some of you guys think differently. But yeah, let's talk about like the intuition, I guess. Um, well, as I mentioned before, like we want to pick the longest. We want to pick the longest subsequence, right? So if we want to pick the longest, usually there are two things that we can do. Well, the first thing is a greedy solution. So we just pick from left to right, and whenever we see one that's pickable, we just want to pick it. The other option would be dynamic programming, right? So I explained before why greedy wouldn't work. So if I draw an example, so let's say we have like AAA, and then we have BBB, BBC, something like this, right? Well, by inspection, if we have this subsequence here, so BBB and BBC, it will be of length 2, and it will be longest, right? But if we use greedy, we would have picked this, and we would be like, oh, none of these work, so we can't extend our thing anymore. And yeah, so I think like that's why greedy wouldn't work. I think like maybe if you try. Wait, yeah, actually that wouldn't work as well. So maybe your question is something like what if we just check um every um every word, and we try to find the longest subsequence using um using a greedy approach. So we pick the one that is usable, and then we just keep going. Well, actually, that also might not work. So imagine you have like a longer subsequence that's like I don't know, like here, and then you have like BBE, BBF. Let's say something like this, right? BB. Let's do this as like CBB. Let's say. Well, obviously A wouldn't work, like links to nothing else. But when we look at B, BBB, if we greedily pick the closest one, well, actually this one cannot link to any of the next words anymore. So this is like not optimal. The more optimal case is to link here, and link here, and we will form a length 4 subsequence. So that's why greedy wouldn't work. But for dynamic programming, we are basically saying for each word, we want to look back at all the possibilities, and we want to see which one like is the longest. And when we like, let's say like for CBB, when we look at BBB, right? So when we look at this thing here, so this thing, it doesn't matter like what the strings are before BBB, like for its longer subsequence, right? Because we only care about the Hamming distance between like our current word and, well, the immediate word we are looking at. So that's why it doesn't really matter like what it has before. Well, if it doesn't matter, we can just store it, like we can just store the length in a DP state, right? And when we look for the maximum, well, we can just like check all the DP state. So you have like DP0, DP1. You just check all the DP state, and then you can just find the maximum like from these that actually works with our current our current word. And so I think like it is like you can prove it by like exhaustion. So you have tried out all the different possibilities, and that's why DP would work here. And that's also kind of how I thought of like using DP to solve this question. So yeah, I think that's all I want to say for this question. If you have any comments, please comment below and let me know your feedback. Yeah, also tell me about how the screen is. So I'm using a different screen right now. But then, yeah, just tell me like whether I think the resolution is better, but then the like you're not seeing as much code. So maybe like I have to do this, or like maybe doing this is better, so like you can see a bit more. But yeah, yes. So just tell me what you think about the new layout. And yeah, thanks for watching, and I'll see you tomorrow. Bye.